Hello, and welcome to our lesson on calculating the perimeter of various shapes. Today we will build on your existing knowledge to further develop your skills in geometry, allowing you to confidently determine the perimeter of squares, rectangles, and more complex shapes. In this lesson, we'll begin by discussing how to calculate the perimeter of squares and rectangles. Next, we will learn how to find the perimeter of shapes created by combining multiple squares and rectangles. Up until now, we've been focusing on understanding the areas of basic shapes. We've learned how to calculate the area of various four-sided figures called quadrilaterals. We've also practiced finding the area for different types of triangles. With this solid foundation, we are now ready to explore the concept of perimeter, which measures the total distance around a shape. Understanding perimeter allows us to tackle a variety of practical problems, such as determining the amount of fencing needed to enclose a garden or the trim required to frame a picture. Using this foundational knowledge, we can now explore the formulae for finding the areas of squares, rectangles, parallelograms, and trapeziums. This is essential for solving a variety of real-world and theoretical problems in geometry. For example, imagine you are an interior designer needing to calculate the floor space of different rooms in a new building. Knowing how to find the area of these shapes will enable you to provide accurate measurements and make informed decisions about materials, layout, and design. By the end of this lesson, you'll be equipped with the skills to tackle such problems with confidence and precision. Let's get started. The perimeter of a shape is the total length of its boundaries. Think of it as measuring the length of a path that goes all the way around the shape. To calculate the perimeter, we sum up the lengths of all the sides. Let's start with the perimeter of a square. What do we know about squares? Well, a square has four equal sides, and if we call the length of each side x, then calculating the perimeter becomes straightforward. Since the perimeter is just the sum of all the sides, the perimeter of a square is x plus x plus x plus x. Simplifying this, we can say that the perimeter of a square is 4x. This formula makes it easy to find the perimeter of a square if you know the length of one side. Let's go through an example. If a square has a side length of 5 centimeters, we can substitute this value in for x. Therefore, its perimeter would be 4 times 5, which equals 20 centimeters. Now let's go on to the perimeter of a rectangle. A rectangle has opposite sides that are equal in length. If we call the lengths of the sides x and y, we can calculate the perimeter by adding each side. Perimeter of a rectangle is x plus y plus y. Simplifying this, we get 2x plus 2y. Let's move on to an example. If a rectangle has a length of 8 centimeters and a width of 3 centimeters, what is its perimeter? Pause the video and see if you can work this out. Well, if we substitute these known values in for x and y, we get perimeter equals 2 times 8 plus 2 times 3. Simplifying this, we get 16 plus 6, and this adds up to 22 centimeters. Now let's move on to our second objective. For more complex shapes, especially those made by combining squares and rectangles, we need to approach the problem methodically. Here are the key steps which will enable you to do this for compound shapes. Step 1 is to identify all distinct outer edges. Make sure you avoid counting any internal sides. Our second step is to label each side length. Write down the lengths of all the sides around the shape. Step 3 is to sum the lengths of each side, making sure you only include each edge once. Let's consider a shape composed of two rectangles. Firstly, we will identify the outer edges. These are what we need to use to work out the perimeter. Now we need to label each side. Let's imagine we have been told the left rectangle is 3 by 10 centimeters and the right 4 by 8 centimeters. We need to work out the lengths of these two unknown sides, x and y. Let's focus on x first. We can imagine a vertical line going down from x to the base of the shape. This dotted line is also going to be 4 centimeters. We also know that the total height of the shape is 10 centimeters. Therefore, x must be 10 minus 4 centimeters. So x equals 6 centimeters. We do exactly the same for y, noting that the entire width of the shape is 8 centimeters. Y must therefore be 8 minus 3, which equals 5 centimeters. Now let's add these all up to find the perimeter. 10 plus 3 plus 6 plus 5 plus 4 plus 8 equals 36 centimeters. When dealing with shapes like trapeziums, where there's no simple formula for the perimeter, add the lengths of all the sides. Let's go through the 2 steps. Step 1 is to list all the side lengths. Write down the length of each of the trapezium's sides. As before, we then just have to add up all the side lengths. So here, 6 plus 5 plus 8 plus 5 equals 24 centimeters. Sometimes not all side lengths are provided. Instead, additional information like height might be given. If a trapezium's height is known, you can use geometric properties to find missing sides, often involving triangle calculations. Let's show this with an example. If a trapezium has a height of 4 centimeters, and you know one side is 5 centimeters, while another is 7 centimeters, you might use Pythagoras' theorem to find the length of the other sides, x. By following these methods, you can accurately determine the perimeter for any shape, whether it is simple or complex. Let's now practice these concepts with some exercises to solidify your understanding. Let's apply this knowledge to a practical problem. You have a rectangular garden measuring 12 meters by 7 meters, and you want to add a 2 meters wide path around it. What is the total perimeter of the garden, including the path? First, let's calculate the new dimensions including the path. Taking into account the fact that the garden path will add 2 meters in length to each side, the new length of the garden including the path would be 12 plus 2 times 2. This equals 16 meters. We can calculate the new width in a similar way. We need to add on the additional 2 meters from each side again. So the new width is 7 plus 2 times 2, which is 11 meters. Now, we can calculate the perimeter of the larger rectangle. We don't need the initial values of the garden anymore. Instead, we just need to add up each side. We have 2 sides of length 11 meters and 2 sides of length 16 meters. So the perimeter is 2 times 16 plus 11 times 2, which is 54 meters. So, you would need 54 meters of fencing to enclose the garden and the path. By working through these examples, you should now feel confident in calculating the perimeter of simple and compound shapes. In today's lesson, we explored the concept of calculating the perimeter of various shapes, specifically focusing on squares, rectangles, and more complex compound shapes. We began by discussing the perimeter of a square using the formula 4 times x, where x is the length of one side. Next, we covered the perimeter of a rectangle using the formula 2x plus 2y, where x and y are the lengths of the side. Moving on to compound shapes, we learned a systematic approach to finding the perimeter by identifying and summing the lengths of all distinct outer edges. We also touched upon calculating the perimeter of trapeziums and other quadrilaterals by adding the lengths of all sides. We also discussed special cases where not all side lengths are provided, noting that additional geometric properties and techniques such as Pythagoras' theorem may be needed to find missing dimensions. By mastering these methods, you are now equipped to determine the perimeter for a variety of shapes, whether simple or complex. This knowledge will be practical in real-world scenarios, such as determining the amount of material needed for construction projects. See you next time.